This is Dr. Jeevitha from Department of Physics. Today we are going to see the topic CO2 laser. So what is CO2 laser? It is a gas laser, right? So in a molecular gas laser, laser action is achieved by transition between vibrational and rotational level. Usually if you see endoc laser or some other laser, it is an electronics transition. It happen basically depends on the electronic transition. But CO2 laser, it will happen because of the vibrational transition. There are three types of vibrational. We'll call that as symmetric, bending and asymmetric. So by seeing this diagram, you can see the carbon is stable and oxygen, it has moved on the symmetrical. And in the bending, if you see, the carbon is at center, the both oxygen, it will crossly move. So up and down it will move to carbon to oxygen and carbon to oxygen. Similarly, if you see symmetric, the carbon is, if the carbon is going rightward, the oxygen will go towards the left. In this case, if you see, the symmetric is changing to a bending, or the bending is changing to a asymmetric, or the asymmetric is changing to the symmetric. Whatever transition happen, there will be a loss of energy. That means release of energy. That energy is nothing but laser will call here. Let us see the construction of CO2 laser. So you can see again the elliptical cavity was here and it was connected with the power supply, and the both end was connected with reflecting mirror. One end is connected and covered with fully reflecting, another one is partially reflecting, because in the partially reflecting mirror only we can expect the laser, right? So in the top there is helium, nitrogen and carbon dioxide. The mixture of three gas we are keeping inside the cavity. Let us see what will happen. This is the construction, and now the working we will see. So we have nitrogen and electron. So basically we have electron with the kinetic energy, and electron is fighting with the nitrogen. What it will happen, the nitrogen will collect all the energy from the electron and the electron will release its energy. So the nitrogen molecule is go to its excited state. Similarly, the nitrogen have some energy now and it is fighting with the carbon dioxide. Now what it will happen, the carbon dioxide will absorb all this energy and the nitrogen will release its energy. So the same thing happening by seeing this energy level diagram. So what I said, the electron is fighting with the nitrogen. The electron basically have some kinetic energy. So the nitrogen is absorbing all its energy from electron and it is going through the transition, transition in the cells from ground state to excited state, and it will transfer energy through the collision for carbon dioxide. How? The nitrogen has some energy and it is fighting with the carbon dioxide. Now in this state, carbon dioxide has absorbed all its energy and nitrogen will lose its energy. So here if you see this diagram, nitrogen, it is from the ground state to, it went to excited state and it passed its energy through collision. So here in carbon dioxide, E1, that is energy state 1. First state 2, it is went to the excited state 5, higher energy state. So from there, suppose we are taking that E5 as an symmetric. So from symmetric to asymmetric, when the electron is coming to E5 to E4, it will reduce some laser, that is 10.6 micrometer, or some energy level 5 to energy level 3. If the electron is passing, it will release some energy which is 9.6 micrometer. So what I said, either from symmetric to asymmetric or asymmetric to bending or bending to symmetric, whatever transition happen, it will release some energy. After a certain time, it will come to ground state without reducing any energy. And these are the application. As I said, in industry it used to cut and welding or drilling any materials. In medical, it is used to do for surgeries like skin, dental, etc. In military, it is used to find the range finder. And the advantage is high power and efficiency, and it has a good beam quality and long operational life. And it has a limitation bulk setup and required gas handling and cooling. Thank you.